Hi, welcome back to Algebra 1. Today's lesson will be about systems of equations. First, let's refresh what we did last week when we looked at linear equations of one variable. Can you remind me what a variable is? Good. A variable is something that we use to represent a quantity. Usually we use letters like x or y, and it can represent anything and take on a range of values. And when we had one variable in one equation, we used that equation to figure out which values of the variable make our equation true. Can you give me an example of the sort of equation we looked at last time? Good. That's a great example. 8x plus 6 equals 4. Good job. And we could solve this equation for what value of x makes this equation true. Now we're going to take a look at multiple equations with multiple variables. Together, these equations will form a system. Within the system, a certain variable represents the same quantity throughout our system. And to solve our system, we need at least as many equations as we have variables. So if we have 2 variables, we're going to need 2 equations. 3 variables, 3 equations, and so on. Usually, a system will have one distinct solution. That is, one combination of x and y that makes all of the equations true. What questions do you have before we take a look at an example? So if you take a look at your worksheet, you'll see our first example of a system of equations. You have 2x plus y equals 5, and minus x plus y equals 2. This is a system of equations. We have 2 equations, each with 2 variables, and it tells us about the relationship between x and y. And we're going to have several ways to solve these systems. One will be by graphing, by substitution, and by elimination. Okay, so first we'll take a look at the graphing method. So let's look at the steps you need to solve a system of equations by graphing. First, you're going to put your equations in slope-intercept form. Then, on the coordinate plane, you're going to graph your equations. And then you're going to look for the intersection. Where do those 2 lines intersect each other? It's at that intersection point where our solution will be found. The distinct combination of x and y that makes both equations true. Okay, so go on your worksheet and try that out. And I'll check in after you do each step. Okay, let's put our equations into slope-intercept form. So we solve for y. We get y equals minus 2x plus 5. And our other equation, minus x plus y equals 2, well, that just becomes y equals x plus 2. Good job. Now we need to graph these. So take a moment on your worksheet, use the coordinate plane there, and graph these 2 equations. Okay, let's see how you did. So we have our equations in slope-intercept form. Y equals mx plus b. So in your own words, this m here, what does that represent? Good, it's the slope. Right, and it tells us for every unit that we go to the right, how much do we go up or down? So let's start with our first equation, which was y equals minus 2x plus 5. We have the 5 here as our y-intercept. What does that mean? Good. This is the y-axis here, and it tells us that our line crosses the y-axis here at 5. And for every unit we go to the right, we go down 2. And then we just connect the dots. Good job. How about the next one? It looks like you did that one right too. And for every one we go over, we go up 1. Where do these lines intersect? Right here. And the coordinates there are 1, 3. So that's how we solve by graphing. What questions do you have about the graphing method? Okay, so let's take a look at our next method. It's called substitution. What we're going to do is we're going to take one of our equations, solve for one of the variables, and then take that substitution and substitute it into the other equation. What we're left with is one equation with one variable. Let's take a look at that. Let's go back to our system. 2x plus y equals 5, and minus x plus y equals 2. Which equation would you like to do first? Okay, we'll do the top one. Which one should we solve for? Okay, we'll solve for y. And we already did that in the graphing stage where we put these equations into slope-intercept form. So we have minus 2x plus 5. Now what do we do? Good, we take this here and we substitute it into the other equation. So we'll have minus x, that stays the same. And then we add y, and we use our substitution here. So we're going to have plus negative 2x plus 5 equals 2. Now what we have to do is combine like terms. Can you remind me what we mean by combine like terms? Good. It means adding, subtracting terms that look the same. So these two x's we can combine. If we have negative x minus 2x, good, minus 3x, plus 5 equals 2. Good, then we subtract the 5. Minus 3x equals negative 3. So x equals 1. Now we can go back to our substitution. Solve for our other variable. So we'll have minus 2 plus 5. That's 3. We get the same answer that we did with the graphing method, and we should. You should get the same answer for your system, no matter which method you use to solve your system of equations. What questions do you have about the substitution method? That's a great question. It doesn't matter which variable you substitute for or which order you do the equations in. Sometimes it will be easier to go one path rather than another, but they will all get you the same answer. Good question. Okay, so now we're going to take a look at our third method for solving, and that's called elimination. What that means is we're going to add or subtract our equations in such a way that one of the variables is eliminated from the problem. Usually we'll have to multiply one or both of the equations by a constant so that the elimination actually occurs. Okay, so let's go back to our same system that we've been working with. 2x plus y equals 5, and minus x plus y equals 2. And we can just add equations together. So let's take a look at what would happen if we just try to add these equations together without any multiplication. So I have 2x minus x is x, y plus y is 2y, and 5 plus 2, 7. So this didn't eliminate one of our variables. So we didn't do it quite right. So like I said before, what we have to do is multiply one of the equations by some constant. When you multiply all the terms in one equation by the same number, you don't change the equation. But we're going to do that so that we can eliminate one of our variables. How do you think we could do that? Good, that's great. We can multiply this whole equation by 2. Let's see what happens. So, minus 2x plus 2y equals 4. Because we multiplied each term by the same number, this equation is exactly the same. Now let's try adding this first equation with the third. So we'll have 2x minus 2x, 0x. Good. That's exactly what we wanted to happen. We have y plus 2y, that's 3y. And 5 plus 4? Good, 9. Now we have 3y equals 9. That means y equals 3. Good job. Now we can use any of the other equations we have to solve for x. And we know from before that x has to equal 1. Good. So what questions do you have about the elimination method or any of the other methods we've seen before you try an example on your own? Yeah, that's a great question. It really depends on the system itself, which method is easiest. Sometimes graphing will be easier. Usually you'll want to stick with substitution or elimination. When you're first starting out with systems of equations, it'll seem like substitution is easier, but the more you practice with elimination, the easier it will become, and a lot of the times it will actually be the easier method. Good question. Okay, so now on your worksheet, there's an example. Try solving it by substitution and by elimination, and then use the original equation to show that your answer is correct. Okay, take a few minutes, and then we'll check in and we'll see how you're doing. Okay, now that you've had a few minutes to go over that, let's see how you did. So let's start with substitution. So walk me through how you solved the problem. Okay, you solve for y in the bottom equation. Good, so we'll subtract x from both sides, and we'll get that y equals 8 minus x. Good, we plug that into our other equation, so we have 3x plus 2 times 8 minus x equals 19. What would you do next? Good, so we have 3x plus 16 minus x equals 19. Close, but there's one issue you made right here with your distribution. Good. Remember, you have to distribute the 2 to everything that's in the parentheses. So here we'll have minus 2x. Good. It's good to catch your own mistakes. Okay. Good. So we have 3x minus x is just x plus 16 equals 19. Give that x is equal to 3. Good. And then we can use our substitution here. And we have that y is equal to 8 minus 3. And that's 5. Good job. Now we'll try the same system, but we're going to try it with elimination. So what was the first step you did when you try to solve this system by elimination? Good. Multiplying the bottom equation by negative 2. So let's see how that works out. So we'll have minus 2x minus 2y equals negative 16. Then we'll add this top equation with the bottom equation. 3x minus 2x, that's x. Plus 2y minus 2y, they eliminate. And we're left with x equals 3. Good job. So here's a good example where you see that elimination was kind of easier than substitution. We had less algebra to do. And when you have less algebra to do, you're less likely to make a mistake. So now we can just use this equation again up here to solve for y, and we get 5. Good. Now, finally, we want to check this answer. We want to use our original equations and make sure that both equations are satisfied with the values we got of x equals 3 and y equals 5. So let's plug in the values we got. So we have 3 times 3 plus 2 times 5. 9 plus 10, that's 19. So first equation, we're good. Second equation, x is 3 plus y is 5 equals 8. Both equations are satisfied. We must be correct. Okay. Any questions about how we solved this problem? Great. Okay. So now take a look at your worksheet. There's another system for you to solve. Solve it any method you'd like. And in a minute or two, we'll come back and we'll talk about it. Okay, now that we had a few minutes to try that out, it seems like something strange is going on, right? So what did you try to do first? Elimination or a substitution. Okay, so how did you do that? Okay, so you use the first equation, solve for y. 3 halves minus 2x, good. Plug that into the bottom equation. 8x plus 4 times 3 halves minus 2x, 6. 8x plus 6 minus 2x equals 6. Oh, good catch, thank you. That's 8x. Wait, 8x minus 8x is 0, and we get 6 is equal to 6. Well, that's always true, right? It didn't matter what value x was. 6 is always 6. So something's strange here, and if you did elimination, you'd see you get the same sort of result. So let's try graphing this. So take a moment, put those in slope-intercept form. Right, and what did you get? Right, for both equations, when you put them in slope-intercept form, you get the same thing. 3 halves minus 2x. So if I graph those, what are they going to look like? Right, it's going to be the same line right on top of each other. So if an intersection between two lines represents our solution, how many solutions do we have here? Right, these lines are always on top of each other. They're always intersecting. And what the term we use here is infinite solutions. It means there's an infinite number of combinations of x and y that satisfy our two equations. Now, that doesn't mean that any combination will satisfy our equation, but there is an infinite number of combinations, infinite solutions. And if you look back on your worksheet at the original equations, you can see that the second equation is just the first equation multiplied by 2. So we didn't really get any new information between those two equations. They're really the same equation. One just has everything doubled. What questions do you have about this? Okay, let's look at another one. Go back to your worksheet. We have another system of equations. And take a few minutes and try working that one out. Okay, now that we had a few minutes to try that out, something strange is going on again, right? So, how'd you try to solve this? Elimination? Good. How did you try to solve this by elimination? Good, we can multiply this bottom equation by -2. And we got minus 10x plus 2y equals -4. Ah, I wrote the problem down, didn't I? Wrong. That makes sense? Thank you for catching that for me. Okay, so we'll multiply our equation by +2. Good. So we'll have 10x minus 2y equals 4. So if we add these equations, we'll have minus 10x plus 10x, 0. 2y minus 2y, 0. And then what we'd be left with is 6 equals 4, which is never true. Doesn't matter what values of x or y are, 6 is never equal to 4. So again, let's try graphing this. Put them in a slope-intercept form, and what do you get? Good, so we get y equals 5x minus 3, and y equals 5x plus 2. What do you notice about these lines? Right, they have the same slope, and when two lines have the same slope, what do we call that? Parallel, right. So if I try to graph these, what are they going to look like? Something like that. So if a point of intersection represents a solution, how many solutions do we have here? None. These lines never intersect. So here's what we would call no solution. There's no combination of x and y that satisfy both equations. What questions do you have about this? Okay. Good. So far we've been looking at two variables, two equations, but there's really no limit to the number of variables we have. So let's take a look at an example where we have three variables and three equations. And you can use any method or combination of methods that you want to solve this. Now, when you have more than two variables, graphing will probably be too difficult. So with three equations, we'll usually just stick to substitution or elimination. But the principles are all the same. So take a few minutes and try to work that out, the equations on your worksheet, and then we'll check back in and see how you're doing. Okay, now that we had a few minutes to look at that, let's see how you did. Okay, so we have this system of three equations, three variables. Notice that not all the variables are present in every equation, and that's okay. So how did you try to solve this? Use substitution, okay. So what did you do first? Okay, good. So you have x equals 6 minus z. And then from the second equation, z equals 3y plus 7. Yeah, and you can kind of do another substitution in here by plugging z in. So you'd have 6 minus 3y minus 7. And that's just equal to minus 1 minus 3y. Good, so now you have everything in terms of y. So just plug that into our last equation that we have. So that will become 2 times 6 minus z plus y plus 3y plus 7 equals 15. Good, and then you're going to end up with, from the other substitutions you made, 12 minus 6y minus 14 plus y plus 9y plus 21 equals 15. Good, collect our like terms. We have 19 plus 4y equals 15. 4y equals negative 4. Y equals negative 1. Good, so that means z will be negative 3 plus 7, that's 4. And x will be 2. Good job. The last thing we can do is go back to our original equation. So look on your worksheet and we'll test our values. Does x plus z equal 6? Yep. Does minus 3y plus z equal 7? Yep. Does 2x, which is 4, plus y, which is minus 1, plus 3z, which would be 12. Does that equal 15? Yep. Right, so these all work. So that means our equations are correct. What questions do you have about more than two variables? Okay, good. So before we wrap up, we just have a few summary questions. So can you tell me, what is a system of equations? Good. It's basically just a collection of equations with variables that mean the same thing. So how can we solve a system of equations? Good. we have three methods. Graphing is one, substitution, and elimination. Good. So let's talk about those methods. How do we solve by graphing? Right, we graph the lines. And where's our solution? At the intersection. Good. So if two lines, we graph them, they never intersect, what does that mean? Good. No solution. What if we graph the lines and they're right on top of each other? Right? Infinite solutions. Good. So, do you have any more questions before I turn you loose? Great. Good job today.